Okay, hi everybody. This last idea within circles is talking about the intersection of two separate circles. There's some good news. We don't actually need to find out where the circles cross, so we don't need to find like these coordinates like we did with the line and the circle. And we only need to look at the conditions for them crossing instead. So we just need to know like, what happens when the circles are separate like this, what happens when they overlap, what happens when they just touch, and so on. Now, a little bit of algebra. We're going to be using the letter D to represent the distance between the two centers. And we're going to be using R1 and R2 as the radius for circle 1 and circle 2 respectively. Okay. Let me just open the example file that I've got here already. So we don't need to worry too much about these values. I'm sort of moving this around as I need to, but the radiuses are 3 and 2 respectively for the blue and red circles. Now, as you can see at the moment, the circles are not touching. We've got the radius 3 and the radius 2 there, and we've got an extra bit of distance in between here. Now, what we're going to compare is we're going to compare the distance to the sum of 3 and 2, which is 5 in this case. And if the distance is greater than 5, you're going to see this situation where the circles don't cross. And we've got that here. The distance is currently 8.6. Okay. And if I move the circle around, even if I bring it in quite close, you can see that the distance is always greater than those two radii together. It's always greater than 5. If I bring it right in, you can see that the distance over here, it's getting closer to 5. And when the circles just touch like this, the distance will be equal to the two radiuses together. And if the circles overlap, if I bring this in, there we go, you can see that the distance is now less than the two radii together. So that's describing the main three situations. Either the circles won't overlap, the distance between them will be too great, they will overlap, or they'll just touch. There is a fourth slightly weird situation where you get one circle sort of intersecting the other, sort of just touching the other, but internally. And that happens if the difference of the two radii match with the distance between the centers. You don't see that situation very often, but it's good to keep in mind. Now, let's have a look at some examples in notes on page 114. We've got two circles, and we just need to decide whether they intersect. And if they do, we need to say how many times they cross. The main thing to break down here is what the centers and what the radiuses are. The first circle is going to be quite easy to do that. I'm going to call that C1. And the center for the first circle, I can just read this off basically, is going to be -2, 3. And the radius is going to be 5. This other one, I'm going to have to complete the square and all the rest to work this one out. So I'm going to rewrite it like so. I'm going to complete the square for the x values. It's going to be x -2 squared, take away squared. The y values is going to be y minus squared. I rearrange this equation. The ones cancel out. I'll take the 4 over. Just going to end up with a 4 over there. There we go. So a bit more work to get to that point, but we've got a center at 2, 1, and we've got a radius. Root 4 is 2. Okay, so a little bit of a faff getting there. But now that we have those, we can proceed. So I'm going to add the two radiuses together, which is 5 plus 2, which is 7. And now I'm going to calculate the distance between the centers. Okay, so it's minus 2, 3 to 2, 1. The distance is, let's see, so the change in x, I've gone from minus 2 to 2. That's a change of 4. And the y values, I've gone from 3 to 1. That's a change of 2. 16 plus 4, which is 20. And root 20 is around about 4.5. I'll check that on the calculator in just a moment. So what's happening? The distance is 4.5. The radius is 7. So the distance is less than sum of the two radiuses. What does that mean? I know what it means, but if you need to check, we can. Let's go back to our diagrams. Distance is less than the two radiuses. Oh, here we go. It's this situation here. Cool. So the circles do intersect and they overlap. 2 points of intersection. Nice. Let's have a look at one more example. This time, it tells us in the question that the circles do not intersect. We kind of have our answer already. We just need to check that it works out the way we think it's going to. If the circles don't intersect, we'd expect the distance to be greater than the sum of the two radii. All right, let's get everything down then. So the two radiuses, call it circle 1 and circle 2 again. The center of this circle is at 1 minus 2. And the radius is root 1, which is just 1. The center of the circle C2 is minus 5, 4. And the radius is root 4, which is 2. The two radii together, they add up to 3. But the distance between the centers okay, let's see what are we going to get here. So 1 to minus 5. 1 to minus 5, that's a change of 6. Minus 2 to 4, that's a change of 6 as well. It's going to give me root 36. The root of 36 plus 36, which roots 2. And I don't know the exact value of that, but I'm pretty sure it's more than 3. Look. 8.5, there we go. So the distance is around about 8.5. The sum of the two radii is 3. So I've got distances quite a lot more than the two radius, and that means the circles do not cross. There we go, nice.